Okay, my friends, get ready, get ready, get ready. This is not meant as any medical advice to do this or do that. This is research, and here's where it starts. Life could not exist without enzymes. Essentially, enzymes are biological catalysts that speed up chemical reactions. A catalyst just means it goes, instead of taking a year, literally, to make this chemistry happen, which would happen, but it would take a year, it does it all done. And that's what a catalyst is. It makes something happen instantaneously. Where do you get catalysts from? Where do you get enzymes from? Okay, this was the best source of information I could find. This is called Ultra Clear, and it's bacteria versus enzyme versus chemicals. Well, what is the difference? What's the similarities? What are bacteria, enzymes, and chemicals? All right. Bacteria are living cells. They're alive little buggers, and I'm going to show them to you. They have the capability of consuming, which is eating the wastes of different types, reproducing. They can make themselves, just, repopulate themselves, and actually producing the enzymes. These are the catalysts. These are the things that are required for life. Listen to this. Better said, bacteria are the factories. Bacteria manufacture. They're the factories that produce the enzymes. If you don't produce the enzymes, you don't produce the chemicals. All right, when the right bacteria are present in the right quantities and the right conditions, they produce enzymes, and they do it very economically because that's their job, and all they do is squirt them out. And what I'm going to show you right there is nothing more than enzymes coming out of bacteria. Wait till I show you. I mean, it's unbelievable how simple this is, really. All right, here's what I missed originally. I didn't realize this, but fortunately, the probiotics I've been taking have the live probiotics in them, the live bacteria. This I didn't realize. I thought all you really needed was the enzymes, but no, you need more than the enzymes. All right, enzymes, which are the catalysts made from the bacteria, are not capable of consuming the wastes. I forgot all about this. So they cannot consume the sludge or the ammonia. Rather, all they can do is convert complex wastes, which is the trash in your system. And I'm going to show you in the biology book over here how this is all done in the lymph nodes and the lymph system. It's interesting. It's very interesting, but it's very obvious. And this is what skin cancer and lymph cancer is basically you don't have the right bacteria to break down these products, and they become invasive. That's what it looks like now. So here's what happens. The enzymes are not capable of consuming waste. So you need really bacteria to come in and eat up and consume the waste material. Enzymes alone will not do that job. An enzyme product only has half the tools. You have to have the bacteria living alive as well as taking these enzyme supplements. So it appears that the living ones are necessary. Now, chemicals can oxidize sludge and ammonia, but only very harsh and dangerous chemicals can accomplish this job. Well, in your body, it's all done automatically by the enzymes. They know how to do it without hurting you. That's their job, is to do this, because they are bacteria living in your body that create these enzymes. Now, here's the issue. If you start taking antibiotics, and here's the problem with the COVID people, a lot of them been hammered by antibiotics, and they still are getting damaged. 59% long COVID patients suffer from organ damage a year later, and it's probably most of them will never recover until they get that right bacteria back in their body to consume these wastes. Now, I'm going to show you in the books exactly how this is done in your body, how your body deals with waste, and it'll make it much more obvious. And we're going to look at all my little pictures and things about you know, what bacteria do. This is what bacteria do. They live in you, and you have thousands and thousands and thousands of different species. Every one of them spits out a different chemistry. One of them might spit out something like this little chain here with all these colors in that row. Another one the colors might be like this, a little different. Another one, the colors are going to be a little different, but they're all going to be a string. And they're going to be and the colors mean the codes. And the codes turn into DNA and RNA. All right, so the bacteria squirt out a little bead like that. It comes out, and then it programs. Messenger RNA, transfer RNA. It transfers the codes into a string of messenger RNA, and then it happens a couple of different ways. They can use that code to make DNA and to go in and start up other cells to take over other cells. That I'm not 100% sure about what happens with that RNA, but I know that once it comes out, it's a code. And that code, when it comes out, it turns into a protein. Protein comes out like this. So it all comes out like that, and then all of a sudden it goes, and all these different magnetic signatures have to be exactly identical, and they are complex as you could possibly imagine. And that is what does the chemistry in it. That's the only reason you have these catalysts and these enzymes. If you didn't have the enzyme, you cannot do the chemistry. This one tiny enzyme, one molecule, can go up and hit 100,000 other molecules that have the same magnetic signature. They have to be in like a tumor-like thing. This thing will come up to it and go, bam! And because of its magnetic polarities, it'll do what they call click chemistry. Snap! And it will shoot out through the speed of light, all through that whole tumor, kill it all in 1 second. All done. 100,000 of them. And this guy won't even get hurt. He just went up and clicked it. And then he'll just go floating around and find some more. Click, click, click. And he's killing all these things. When it's all done, he goes back to sleep. And then he breaks up into more particles like this. So you can reuse them. These are amino acids. And this goes pretty deep, and I'm pretty deep into it. I like this stuff. And what happens when you get invaded, your bacteria here, this guy here is not alive. He's dead. That's called antibiotic. You took something and killed it. And that's what happens with these COVID. A lot of them are getting slapped. You wouldn't believe the amount of antibiotics. I'll probably show the article, but if you look it up, how much they're getting for antibiotics, absolutely unbelievable. And then they don't have these repopulation of this probiotics. So at any rate, you have to have these, and they squirt through your system, and here's where they go. You see this little flagella? They can spin 100,000 RPMs. It's like a rocket ship. And some of them have fur-like things on them. Some of them have spikes. Some of them are bald as a cue ball. There are all kinds of different style bacteria. And here's where it goes in your body. Hold on, where is it? Here it is right here. You see that line right there? That's the fluid-filled highway. That fluid-filled highway separates you from the invasive particles that are trying to get through this tissue that separates you from the rest of the world. This is sort of dispensable. This is skin, like the skin, it falls off. It doesn't, you're not going to die from that. But if you get invaded past this demarcation zone here, right here, then you're sort of getting invaded. You can still fight back and control that. But this right here, that line right there, you see those big wide open holes? These are your white blood cells, even though they're dark. And inside there, you have all your enzymes and bacteria and all that stuff. And there's more of them here and there. But here is the real primary zone of penetration. If they get past this, then you got to really struggle. Then you're going to get infection and really hot and burnt, and all that stuff happens to your tissues because your tissues break down because of the invasion. I know I'm starting to get a little carried away with this, but the point is, this is your fluid-filled highway. If you want to understand this COVID and why people are having long COVID, it's because the tight junctions are not tight. They're not making the right kind of chemistry in here because you don't have the right type of bacteria. So primarily it's tight junctions that causes the invasion. And when I show you tight junctions, I'll show you exactly what I mean. And I'm going to show them to you in my mud fossils, because that's how I discovered. I actually discovered interstitium before they knew it even existed. As a matter of fact, this doesn't show it, but this was from a thing that was about interstitium meet your newfound organ. This is from 2018. You could look it up. Interstitium meet your newfound organ. They didn't realize this was here. I'll probably show you that, or I already have shown you that. But this is the fluid-filled highway. This separates you from the rest of the world. But if you don't have the bacteria with their flagella going through the highway, the bacteria do the job. All right, the enzymes break down the chemistry. The bacteria deliver it. You see this? 59% continue to exhibit organ damage a year after experiencing initial symptoms, including those who were not severely affected at the time of their virus diagnosis. This is this new report, shocking report. Now, when you look into what they do, how they take care of these people that have pretty mild to serious infections, they use a lot of antibiotics. All right, my contention is more than likely the people that are getting infected have a pre-existing condition so that they can become invaded, and it's normally considered the tight junctions, and I'll show you that uno momento. However, antibiotics they use to try to cure these people. So they come in with COVID-19, all right, and here's what they do. Antimicrobial resistance, a global health problem. This is the introduction to what they're going to be talking about. Now, let me show you what antimicrobial resistance is all about, and they're really using a lot of antibiotics. Okay, let's take it from this aspect. If bacteria, which is probiotics, which can be killed by antibiotics, if those probiotic bacteria living in you create the enzymes that are necessary for your life, and you antibiotic induce them into killing them, they cannot create the enzyme, therefore you cannot break the molecules, you can't digest the food, you can't do all kinds of things that are required for your life process. Now, what are they doing about antibiotics when you get COVID? Listen to this. Among 106 hospitalized COVID-19 patients, the prevalence of antibiotics was 104. That's 98%. All right, they've received multiple antibiotics. The great common classes of antibiotics used were some of it about 85%, and macrolides seen in 57%. Anyway, antibiotics kill your good biotics. Now, just as well as the bad biotics, they're broad spectrum. So all of a sudden now you lose the ability to fight on a whole bunch of other areas, because certain bacteria create certain things, and one of them is collagens and keratins and the fabric that sews your body together to keep you from getting invaded. It's called tight junction. I call it Slurpees, small leucine-rich proteins. And they make your body so they can move around, but it stays glued together and you can't get penetrated. Let me show you in the mud fossils, which are gigantic. I'll show you the Slurpees. All right, so now this isn't one of Tyson's, but this is a tendon area that comes up, and where these break is what's called abrupt transitions, and there's several of them. You see this one, then down here, and that's how they come from an anchor spot, and then it spreads out as a little bit of a tendonish stuff that's really tight and hard, and then they get into muscle, and then the muscle breaks off easily. But right in here you can see the slurpees. Now I'm going to come into a spot where we're going to find some really good slurpee. You see it right there? All right. This is what is going to be between every single type of tissue. You're going to have that gooey stuff. All right, and in your lungs especially, because your lungs and your digestive system is exposed to everything that you breathe in, and it goes through your body, whatever you take in. Now, if you have the right bacteria and the right enzymes, they will do the job to make sure you're not invaded. Basically, it's as simple as that, as far as I can determine. But you have to have not only the enzymes, you have to have the bacteria that create the enzymes. So you really need both of them, but if you have the bacteria, you should get both of them. Once you kill the bacteria, you have neither of them. And you have thousands of species of bacteria, and you have literally trillions of actual bacteria in you, trillions and trillions. And they flow through that fluid-filled highway, picking up and delivering the goods to make you healthy. And guess where they live? They live in those little pockets right there. And can I prove that? I pretty much can. You see how these are formed? How these are like little pockets like that, little oval looking shaped pockets? Let me show you what they just discovered. Alright, here is the problem. You have to be sealed from the outside world from invading you. Viruses and invading particles are tiny, tiny things. You need tight junctions. They can't be like this and be able to get invaded. This is called the tight junctions. All right, barrier function of the lung epithelium, which is the coating, depends on the so-called tight junctions, the TJs. They're heteromeric protein complexes, and the proteins are these things that make these things. They form a sealing interface between adjacent epithelial cells. So all your cells are individual, and they all have membranes around them, completely separate them from every other one. But they have to be tight and glued together all the time with these small leucine-rich proteins. The damage of tight junctions is a major cause of epithelial barrier breakdown during lung inflammation. The damage to the tight junctions, well, they don't get just damaged by accident. The chemistry of them is not good. And they're sort of floppy, and something can penetrate through it. It breaks open. Now, I can actually show you these tight junctions. And like I say, the small leucine-rich proteins, the slurpees, in my mud fossils. And again, they're gigantic creatures, and everybody knows that I've been showing this, and it's just what it is. It's not, I didn't invent it, I just saw it. You know, let's just start off with this. Every single cell in your body has one of these bilipid layers on it, which means it has to be encapsulated in a membrane. This is a membrane. But you got to let things in and you got to let things out. You got to service all the stuff that's under the membrane, because the membrane surrounds all of the organelles and all this goop that's in the center of them. So you got to let things in and out, and that's what these little channels do. Protein channels, cholesterol's in here, all kinds of things going on. How big do these get? If you held that up in front of you, you'd see through it almost unobstructed because it's so thin. These are the little fluidy filled spots. But there's a layer just like this of all these balls, and a layer of all these balls at the top. And in between there's this fluid filled layer. Now you want to see how big they get? I'll show you how big they, well, these aren't even the biggest they get, but they're pretty darn big. Alright, this is my good friend Tyson Carlson I've been working with for several years now. This is only the lower layer. This is just this layer right here, just this layer right there. And this little squirrely looking thing is one of these. And these are the ion channels, the protein channels that allow things in and out. They put campfires in here and sit around them. This is on the coast of Oregon. He's got absolutely incredible. But this is the lower one. The upper one is 6 feet above. And he's been working on this thing for 3 years. He's got a drone, or maybe even more than that. He's got a drone. He's been doing a fabulous job. And we're starting to understand all the things that we're looking at, which are very perplexing. There's no question that these are just absolutely stunningly large. And then, you know, you have to look at it and try to figure, what is that little thing? Why is that a little different than everything else? Right? Well, there's one right there. And these are these, you know what I'm saying? You really got to do a lot of thinking and looking and, you know, trying to solve these issues. And that's what we do. All right, remember this. Here it is right here. This is what cancer is. And this is what invasion is in general. This is your membrane. Remember I showed you that? You see these little different looking cells here? These are the cells we're going to be looking at in a second. And these break through that layer of cells. And the only reason they can break through is because these can't attack. If they had the right, there's going to be the layer I'm talking about as a fluid-filled highway that this is. And they really never realized this until recently. And this is what has to attack. And they have to have the correct enzymes to go and kill these guys. And then you have to have the right bacteria to go and eat them up. And then we're going to go to the medical journal in a second. I'm going to show you some extremely detailed of what happens in the lymph nodes, what happens in your intestines, in your digestive system. All of that stuff, it's right now I pretty much fully understand it. And I understand the invasion technique and the necessity for these enzymes and bacteria. And the only way you can have the enzymes is if you have the bacteria. And then you have to have the bacteria come over and eat up all the stuff that the enzyme breaks up. It's like a cooperative effort. The bacteria says, okay, I'm going to make the chemistry and we're going to go over there and destroy that. And then he tells another bacteria, probably, hey, I just went over and the guy squirted that stuff out that I made for him. Go over and clean that stuff up. So, you know, they call them macrophages and leukocytes and, you know, it's a little complicated, but I'll make it simple. I'm going to show you how it works. Remember this layer, remember this invasion. Okay, this is as fabulous as it gets. They have come up with a technique so they can watch the actual activity of the microbes in here going doing their job. Now, what they are going to look at is the immune cells that I'm talking about. And I don't know if they even realize it, but I'm pretty sure they do. Hold on one second. Okay, this is unbelievable. This is Seeker. This is Gokul, they did some new research where they developed a lighting technique that they can observe the bacteria and so forth doing their job as they're watching it do it. Now he's watching in here and he just discovers this and he says, the hair on my arm stood up and it's a microscopic universe. These are all like little cellular compartments in here. They're all cells. Now watch.
It's a microscopic universe.
Hold on one second. Let me turn it up. It's a microscopic universe, and he's not kidding. Hold on. Here it goes.
So,
this is an unprecedented view of the cellular world.
All right. You see this? That is those big packages of, the cells, the immune cells, and they're right underneath this fluid-filled highway. This thing here is going to come in and scoop up all kinds of stuff. Now, what it's scooping up, I don't know. I would suspect maybe these are all little, like, peptides. Or they could be polypeptides, which is a longer chain. Some of them are bigger, some of them are smaller. Now, is this scooping them up to take them out in these little balls? Like those are the little balls to me. They look like the things that go out and invade other tissue. And it looks to me like it's scooping them up and packaging together or whatever. Let's just come back a second. And you know what I'm going to do? I'm going to turn the sound off. And I am going to put this in slow motion so that we can watch this. That maybe is the best way to do this. I don't think I've done this. Here we go. Now, Go Call is saying, I couldn't believe what I saw. Let me turn the lights off. So, now, here's what's going to happen. I'm going to stop this as it goes. You see all that? Up here is the fluid-filled highway, right up in this area. This right here is that cell that we were looking at before that was underneath the fluid-filled highway. All right, now here's what's going to happen. They're going to put a light on here that shows the bacteria, and it's scooting around inside there. Watch. Watch, all of a sudden they'll pick it up. Here we go. There it is. And they've got it highlighted in this light. And it's running around, gobbling things up. And it eventually picks up all the stuff that it needs. And it will start to head out to deliver it. Now watch, I got it running real slow, so that's, all right. Now, you see these have turned into round balls? This is real time. This is instantaneous. It's happening. What are these round balls? You see them? I'm stopping and going, stopping and going. It's carrying them out, and it's going out to deliver them as a package. And he said, wow, we never realized this before. Let me show you something that might have a relevance here. All right, you see this? I'm not sure where I got this from, but it's pretty interesting. This appears to be some kind of, intercellular fabric, which is like the interstitial fabric. Now, I don't know why it's... Okay, you saw those little round orbs that the bacteria obviously was skirting. It had to be a bacteria with a flagella, zip, 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 collecting, I think, these. Bringing them out to attack these, which I believe are the invaders. They're pretty ugly looking things. If they're not invaders, I don't want them in me anyway. They're ugly. These guys are nice. These guys are nice and, nice looking guys. So they're going to attack these guys. I think that's what's going on. And this looks like your, vital fleshy area down below. I don't know how this picture was taken. I don't even know where it came from. But I believe that could very well be those things that we're just seeing coming out of here. All right, because let's watch it again. Let's see if we can see those little round balls. All right. There, all of a sudden, that popped out of nowhere. Where did that come from? These are the things I can't explain, because again, this is real time. But it's just popped out with all those balls. Whoops. I started over. Here we go. All right, so he's just looking at the whole broad picture. Now it starts. He says the hair on his arm stood up. He just freaked out when he saw this, because this is the first time anybody's ever seen this. And this goes back about 2 or 3 years. Now, that just popped out of nowhere. Now, see all the balls? And it'll get ready, and then it'll squirt right out through one of these protein channels. Because these are proteins. Enzymes, proteins, basically the same thing. You see the balls? And there they go. They go out to do their job into the fluid-filled highway. Pew, like a rocket ship. Now, there is 2 types of bacteria in you. One of them is a sniffer, and one of them is the killer. We just saw the killer go out to kill or break down something but it goes out into the fluid-filled highway to do its job. There's other ones that are always out in the fluid-filled highway. They don't eat anything, they just sniff. Let me show you as a representation how that works. All right, so this, I can't tell you for sure, but it looks to me like these are those balls attacking, something's attacking something else. Let's go with that for the moment. I think. Now, he's going to be talking about, Gokal's going to be talking about the sniffer bacteria versus the killer bacteria. And the sniffer bacteria doesn't eat anything. And here's how it works. It goes around through that interstitial layer, digging around through here, through this, okay? So this is a sniffer one. And it's just like this. And it's going up through, around here, sniffing around with a chemical signature that is sniffing to see if anybody meets that signature or doesn't meet that signature. And it's somehow it can differentiate between friendly and unfriendly bacteria. If it's unfriendly, it sends a signal to these cells to manufacture that bacteria to squirt it out, and it pow, it kills the guy. And how does it kill the guy? It comes up with some very, very complex looking protein like this, just all exact, and it's be exactly that way every single time or it doesn't work. It gets out there and it goes around and bam, and once it hits one of these guys, don't forget now, you'll be in like a tumor-ish looking thing. All right, here's what a cancer tumor is right here. So this will become floating through this here. And before it ever got through there, that's the key. You got to get it before it gets through. It would go click, and they'd just die. And now your bacteria comes in after the enzyme clicked in here and killed it, and it's just disintegrating. Now, here comes where skin cancer comes in, because we just killed that stuff. But if we don't have the bacteria to come to eat it up, bring it over to the lymph nodes, and then in the lymph nodes you have to have more bacteria and enzymes to convert it into lymph nodes. And I'm going to show you the lymph nodes. So don't forget, we have bacteria looking for things to kill, then we have other bacteria that goes out and kills it, and other bacteria goes out and digests food, and other bacteria does other maintenance jobs in the body. But this is the key. The fluid-filled highway is where your layer of protection is. Okay, don't forget, this is just spectacularly large. I cannot account for that. All I can tell you, I don't know what they eat. I don't know whatever they did, it's here. That's all I can say. This is the skin. This is the fluid-filled highway, basically. And then you have all that interstitium with the balls and all that stuff. And that's down here, and the fluid-filled highway is here. You see, that's how small these things are in us. That's like an electron microscope. Now, here's how big they are in the body of the Earth. And the Earth is basically a corpse. It has corpses all over it. And they're the biggest things you could ever imagine. And these balls, these little black balls, are these balls. All right? And all these straps are really floppy, and they erode and turn into the mud. Now, here's what it looks like right here. All right, all that stuff erodes away as the ocean beats away at it, and here's what it ends up looking like. All right, all the balls separate and land at the bottom, and the red fleshy stuff turns into mud. And this is the red fleshy area, and that's the skin above, which they call the mucosa. And that's the fleshy area, and the balls have just dropped. And this is it right here. Now, can we see that specific layer? Yes, there it is right there. That red layer is the layer we're talking about that protects you. I believe this is it. And it's going to be a different looking layer. It'll be a little more pronounced, as you can see, than the other layers here. And the fluid-filled highway sends the stuff around your body. Ooh, I didn't just notice that. Look at that. wonder if that's an invasion. I'll tell you, there's so much to see. No, I don't think so. Look, there's one over here too. Maybe that's a sweat pore. This is very, well, obviously it's very highly magnified. Anyway, let's just keep going. But these are the interstitium balls. These are that fluid-filled highway, and these are the white blood cells. And we're going to go back to Gokul, and he's going to talk about the sniffer one that goes around, and it's got an exact chemistry to it. All right, so that it knows who to see and who not to see magnetically. Basically, that's what it is. It's like a magnet going around. And if it sees somebody that lines up with this or doesn't line up with this, it alerts the killer one. And that's the one we saw squirting around and went out through the wall. So here's Gokul again. I'm just going to start right from the beginning. I'm just going to go regular speed. I may stop it from here and there to make a point. But it's Seeker, this is Gokul, this is UC Berkeley, and here we go. This is the first time this was ever done.
I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the air
You see, she said immune cells, so that's the one we're talking about, those white blood cells.
of a zebrafish in real time.
Focusing only on the crawling immune cells, we've noticed two classes of them.
Two classes of them. He's going to say the first class is the sniffer. He's going to show it right over here. It'll be just like this. These different little colored beads, and the colors mean polarities. They're amino acids, but they're polarities.
One team was not hungry at all, but it was very active in terms of trying to figure out, what the environment is. There was another one that was kind of slouching around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments.
As it's in real time. I mean, this is just stunning. Now, what I would like to see was that actually those little round balls, whatever they are, that it was scooping up? They looked like it to me. Well, I'm going to tell you what, if that's not what we're seeing in that virus and enzyme attack, I'm not sure whether these are bacterias or whether these are enzymes or what they are. But these little balls appear to be scooped up in here and being taken out and delivered. They sure look like what we just saw a second ago. You see that? Boy, that sure looks like it to me. And that's right in this immune cell. And then it squirts it right out through one of these ion channels or protein channels.
We can actually
Goes
conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of, scooping up its environment.
This is very, very, very incredible. What I would love to be able to do some research on this, but obviously I can't. Anyway, let's just take one more look at that virus attack. I don't know. If somebody knows exactly what this is, I'd like to know. It looks like what that bacteria, and it's got to be a bacteria with a flagella on it, scooping all like it was going around there. And it was scooping up a whole bunch of these things. It looked like to me like it was coming out to deliver them to somewhere. They're taking it somewhere out of there. Now, what were they? They could be bacteria. These could be living bacteria. Or they could be enzymes, or some kind of chemicals. But we obviously have something against something else. These two don't look like they, dance well together. Now, the other thing is this right down here. This almost looks like fibrin. Fibrin is a clotting factor. Was this a wound? I don't know. So we need to look a little deeper in here, but I'm going to tell you one thing. Things have changed a lot, and the medical industry is not really looking into this the way they should. This is probiotics, and well, let me put it this way. If you don't have the bacteria, which means the probiotics, the good bacteria, probiotic bacteria, probacteria, if you don't have those, you're not going to get the enzymes. If you don't have the enzymes, you can't do the chemistry. And that chemistry is absolutely required for life. So if you've taken antibiotics, it's quite likely that some of your bacteria is no longer living or is very weak. So it would be very interesting to see what is the level of bacteria in this interstitial fluid, because it floats through your whole body. Now, it's primarily created in the digestive area, and you have to work with everything in your digestive zone to break down all the things that are coming through. They're absolutely required. And you have to be able to make the correct ingredients to go up and make those slurpees, those small leucine-rich proteins that let your body float all around and still maintain the tight junctions. You don't have the tight junctions, you are going to get invaded by these tiny, tiny, tiny bacteria and these tiny, tiny, tiny viruses. They will break right through those tight junctions and invade you, just like I showed you that cancer invasion. That's cancer normally is a little longer term. It just keeps eating away and eating away and eating away. This type of viruses and so forth are, overwhelming attacks. Let's go with that. Cancers are normally just almost like not taking care of a spot, because you don't have the right bacteria. The bacteria is not there to make the enzymes. The enzyme is not there to protect that particular zone, and eventually it eats a little more. You're in phase 1, phase 2, phase 3, phase 4. Now it's inside of you. Then you got the problem. See, this is basically what happens with the cancers. Phase 1 is when you're just a little nibbling into you, but it just continues because you cannot stop it, because you don't have the enzymes and the bacteria to kill it and break it down and consume it. So it breaks in and more, and it's more and more and more, and these guys keep living in this zone and developing their own little region of space, and eventually they get down through zone 1, 2, 3, 4, and then boom, right into your vital tissue, and then they say, well, you got so many weeks to go or whatever. It's I believe if we get back to the gut care and the correct bacteria levels, which means the correct enzyme levels, which means the correct chemistry, I think that's where we're looking to do to get health. All right, think about this right now. I'm going to show you this. This is, I believe, is possibly the fibrin, which is this right here. I'll show you in a second. But this is a scab that's developed on one of my mud fossils, but it's bleeding, and right under it is the fibrin, which is the clotting fiber. And I think that's what this might be. Now, again, you saw the slurpees, and you saw the cancer and all of that stuff. And this was DNA tested, CAT scanned lungs, and they actually had blood, literally blood coming out of them. Now, let's take a look at this one more time, and then I'm going to show you the fabric that I think might relate to that. All right, so let me back it out of here. All right, here we go. Once again, those look like what the thing was taken out of those white blood cells. This, I believe, could very well be the clotting fiber, because that's what collects the red blood cells, and then the red blood cells form the scab, and then you're repaired. This looks like it's a bunch of guys trying to keep these guys from coming through. Sure looks like it to me. There's certainly a borderline there. Now, here's what the clotting fiber does look like. You see that? You can't really see it, the weave of it, but it's there. And it's there in a weave that's a certain size that fluids can get through it, but not white blood cells. So not red blood cells. The red blood cells collect on it sort of to make the scab. That's what a scab is all about. And that's what the scab ends up being. I had moved it so I could see it. This is in a bone foramen. These are the mud fossils. I have them in every size, every shape, every organ. You have new species. It's quite a change, my friends. Quite a change, as Caesar will attest to. All right. All of these things. You see this texture and this color? That's what these are. Feldspar. Feldspar is aluminum silicates. And what happened in the hot water flood, which this is all from that, the aluminum silicates got what's called nucleophilically substituted into a fabric that was encased everything that was inside. So now all your organic material, like I showed you before, let's get off of the blood and the bone, but this is the same material. Feldspar is feldspar, and it's on basically all of the mud fossils. And that's what protects them. Like, see this lung here? This is the same thing, only a lung has pleura. It's very, very dense. Now the other lung here, it's just completely eroded. All that stuff eroded, and it got down to where all of these are little alveoli. Alveoli are the holes that are in your lung. When you breathe, all of these little holes get filled up with air, and the red blood passes past them, and it picks up the oxygen. And that's what this lung was. It had the same coating, and now it's eroded off. Simple as that. But when it did, well, not all of them, but a lot of these little red ones, actually the blood bubbled out of it. And here's the blood that bubbled right on, right there. This is the lung. This one here, it's all quartz now. Quartz fills in. What happens is silicates replace cavities. You know, the veins of quartz, they call them, that type of thing. And they found a lot of transition metals in those veins because transition metals are in the blood. And transition metals are what does the nucleophilic substitution in your body. They have all kinds of different, what they call oxidation states, which means that they can pinch on. I think it just glitched out on me there. But what I was saying was, the blood is inside these things. There's still blood inside here. This is saturated with blood, absolutely soaked with blood inside. And these all were in this great flood. My buddy Caesar here, his pattern, his feathers are still here. And they all got cooked in this hot water flood, and then they died laying like this. That's why this side is undescript. And that side is a goose. And because of this encapsulation, this nucleophilic substitution and invasion to make feldspar, the inside takes on whatever is in the chemistry of the soils. Was it near a heart where there's a lot of transition metals? Was it near a kidney or a liver or bile or stomach acids or whatever? That is what determines what the end result will be. Some of them will actually come out looking just like they were when the creature was alive. You know, all of the tissue will still be there, looking the same thing, the fascia, the bloody looking stuff. Anyway, this is everything's changed now because of mud fossils. 100% change. All of this has never been understood before, and I understand that. It's not, but you got to look at the reality of the situation that we're in now. It's like this right here. This is a muscle mountain. This is a mountain. This is the guy's van is over here, and this is the connective tissue in the muscle of that mountain. And this is where it starts to get real red and running off. This is where it's going to meet up with a bone or something, which is all eroded away. And then it starts to get into the real red muscle. And I have the same thing here, only it's not quite that large. Not quite that large, but here it is right here. All right, this was right here where the red muscle starts. And you see these little breaks right here? These are abrupt transitions. This is the first abrupt transition where it goes from, this is the tendon part. All right, remember I showed you how that one weaved it back and forth. That was probably in a shoulder area or something. But this is the tendon part, which gives you a little tiny bit of give. Not much, just a little bit. And then it weaves into the muscle, which takes on all this red blood. This has no red blood, almost none at all. These are virtually bloodless. A lot of connective tissue. Then you still have a pretty good hit of connective tissue coming into the muscle. And then as you get out further and further, it just turns into red muscle and just breaks off. Which is, this is the whole thing. And this was where the bone is. All right, you can't see the bone in this one. The bone would be up here. And then this little area right here, this is glue. And I mean it's tough, tough, tough glue. And this little area right in between the glue and the bone, right, and the muscle right here, which is the muscle and starts and takes off. That's in another abrupt transition. So you have to start to understand how the body's constructed. And this is completely flushes with blood. I mean, your muscles are absolutely saturated with blood. And I can show that as well. I show all these things. I'm not just making things up that I can't support. You see this? That is muscle. That's muscle. You see that? That's blood. Saturating through the muscle. Feeding all of these sarcomeres. You see these little blocks? Those are sarcomeres. Now you want to see what muscle looks like in the microscope? I'm glad you asked, because I just happen to have some around here somewhere. There you are. Those are those sarcomeres. You see them? These are real sarcomeres, and this is what they look like on the, electron microscope scale. Here they are here. Moved over to here is closer up to them, and right up here is right on top of them. Now I have another shot showing them in right here. Here's what they look like when they're sort of relaxed. And they shift across here into there. And then when they pinch together, they end up being like this. What is the difference? The difference is there's red gooey stuff, and then there's tight little slats of connective tissue. And the red gooey stuff is in between every one of these little lines, and I mean there is a bazillion of them. And that red stuff drains out, and the red stuff along the side drains out, and you end up with these chunks and blocks. And those are the sarcomeres, as I just showed you. And you will find them right like this, only if this had eroded, if this was completely eroded, these blocks would all be separated with this line running down the middle. So there'd be a chunk and 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 a chunk. That's what they would be. And then there would be cavities here and there and veins, and like this looks like it might be a vein going back. But some of these are like big gusher spots of arteries. I don't see one that I can clearly see, but I can tell you right now, this area here is heavily infused with blood. These little black ones, I believe, are the veins that pull them back, pull the blood back. Because once you use it, it's got to go back. But anyway, this is the sarcomeres. And again, if they eroded, this is what you would have, is little blocks. And we can find those blocks in a number of places. And I mean big ones. You see that? These are all sarcomeres, these little tiny blocks. Can you see that? You just can't even imagine how complicated the human body is. And how tiny these little devices are in our body and how elegant they are constructed, but they need to be maintained. And you have to have the right chemistry, which means you have to have the right bacteria to get the enzymes to do the chemistry. Simple as that. All right, check this out. That's bundles of muscle. You see that? These are bundles of muscle too. Okay, I'm going to show you this. This is freaky. I'm telling you. I think these are the islets of Langerhans. I'm not kidding. All right, I'm going to focus in on the pancreas in a second. But what we're looking at now is nerves and the nervous system, the endocrine glands, which there's about 8 of them in a body. The main one, to me, is the pancreas. And this is the one here that creates a ton of digestive juices. Remember I showed you those things that were laying there? I think those are those little islands of Langerhans. And then there's some other things in there that are not the islets of Langerhans, but they create a ton of enzymes in that particular body part. And then, hold on. Oops. All right, then you have your stomach lining and so forth, and all of the different lining that coats your, whoops, did that knock it over there? Hold on. All right, now these are where your digestive system takes in all of the different food and it passes by and all of the different things that in you. Some of it's good, some of it's bad. And you have to be able to deal with it. And that's how these different membranes deal with them in different ways. They absorb them. Some of them absorb fluids, some of them absorb all kinds of chemistry, some of them, like the stomach, secretes acids and so forth and works with it that way. It's very, very complex chemistry. And hold on, there's some more here. All right, so let's just go back to the beginning. Here's the problem, is tight junctions in the cells that are the barrier between you and the rest of the world. I don't care if they're in your intestines, in your throat, in your stomach, in your lungs, or if your skin has issues, you have kind of issues with your outside skin, everything, and you may live in an area where there's toxins and there's environmental things that, like all these guys that are dying from these burn pit exposures, they were just sitting around, standing there watching this stuff burn, inhaling all of these chemistry that would kill the bacteria in them. And that's why they died, most of them. That's my impression of what's going on. Now, we can intervene, I think, with living bacteria that repopulate your attack the dead bacteria. Which I take probiotics regularly, twice a day, and they're good ones too, and they have living bacteria in them, which I can't recommend anybody take anything, and I'm not going to even tell you what I do take, and I'm not going to respond if you ask me, because I don't give advice, but I do. The ones I do take have a living bacteria in them, and they're not cheap, they're not really crazy expensive, but I'll tell you, if they help you and you have the bacteria and the products in you, you just feel pretty good. And then the other thing is something that makes your gut active, like Metamucil is something. I'll name that name brand because that's what you see, Metamucil. It's a fiber, and what it does, it's like a prebiotic and a probiotic, and it does all kinds of biotic things in your gut, because this bacteria you're going to eat for these probiotics needs something to live on in your gut. And that's what, that's why they say you should be eating fermented foods, and you should be eating this, and you should be eating a lot of roughage, and, things that plants, that's something that can live on these things down there and eat them to stay healthy, the bacteria, because you got to have healthy bacteria in your gut. And once they establish themselves, and you continue to feed them well and not assault them with antibiotics and so forth, they will produce the enzymes to make you healthy. But anyway, I'm not going to give anybody any advice. All I can say is, you know, what you want to have is good probiotic activity going on in your microbiome. And they're fully understanding this now. It's very, very fully understood. But the medical industry is very, very reluctant to come forward with anything that puts them in jeopardy. And if you said to me, well, my husband died or my wife died because you told them to take probiotics, well, then the guy said, that's not your medical that's not authorized, basically. And basically that's what they tell you right now. You can't get a fecal transplant unless you fail all of the traditional medicine, and then they'll give it to you, and then you have a 90% cure rate. Why can't you get that in the beginning? And there's almost no complications ever. And they give you all these things for C. diff. And, you know, you have to take them before you can get the fecal transplant. They won't let you have it without it. But then once you get it, boom, it's almost instantly you're cured. I think it's like a 90% cure rate. And that's after you've been really seriously sick. Why don't you take that before you get seriously sick? I think it should be up to the patient, but and again, I don't give that advice. But anyway, what we need is to have tight junctions. You need your proteins, you need your enzymes, you need your bacteria, all the chemistry's got to be there. The bacteria's got to come back and clean it up, and then it's got to take it over to the lymph nodes. And let me show you how the enzymes are created and how the lymph nodes deal with the products. All right, this is important. This is the lymph node. This is where you get melanoma, which means skin cancer, and it's not good. Now, what does a lymph node do? It's a garbage dump. It's literally a garbage dump. And you have lymph vessels that carry in crap, just nasty stuff. And then inside of here, I believe, is where your bacterial enzymes reside in copious quantities in every one of these lymph nodes. They're little black balls. I can show you where they reside in the body. They're all over the place. And they're very close to where you have major arterial, I think it's primarily artery, but anyway, we'll look at it in a second. But you see these valves in here, these lymph vessels. What you're doing is you're cleaning the blood, and then you're dumping it. All right, and then it goes out into your urine or your however it gets out of your body. I'm not sure at this point, but this is what has to deal with it. And when it can't deal with it, they get broken through. Like I showed you how it breaks through the walls. The toxins, you get overwhelmed. You can't deal with it, and then then starts to metastasize. They call it. And what happens because you have a fluid-filled highway. So if one part of the highway doesn't have the stuff, the other part is not going to have the stuff either. It's not like just one that gets affected. One will get affected quickly. Probably there's going to be an area that is the source of infestation. And then they say, oh, well, now it's spreading. Well, it's spreading because you still don't have the stuff anywhere else either. So somewhere else is going to pop out next, and somewhere else is going to pop out next. And before long, you're so invaded, you die. And that's what melanoma is all about. All right, this is a good time to point out the differences between an artery and a vein and the lymph node, the lymph vesicle, lymphatic system vesicle, which allows, you see these little things? Those are valves. So it can go this way, but it can't go back. You see, it can squirt through that little thing, but it cannot come back. Same thing with the veins, because the veins are bringing back bad blood. Bad blood. Now, it can only go this way. So it can't go back into your body. It's already used. Artery, totally different. Artery go this way, that way, upside down, over and around in circles. It doesn't any way you want. Because the artery's coming in with the good blood. Now, what happens with the lymph node? Can you see that? Yes, you can. You see these veins, these valves? Right around the main blood supply, leading out. And then you see all these little ones coming in, and they have the valves going the other way, so whatever is pumping in here, the lymphatic fluids are going in here, they get clean, and then whatever happens, they blow out through this big tube, the nasty stuff. It appears to me. We got to dig through this. There's a lot to look at, but if you can't break down and destroy the stuff that's in here, first of all, you got to break it down, so you need an enzyme. Case closed. That's the chemistry. Then you need a bacteria to gobble it up and bring it over and carry it over and deliver it. That's apparently, just sounds like to me. And the bacteria, the enzymes, the chemistry, the fluids, the transition metals, all of that stuff works in harmony when everything's good. And when you miss the bacteria, something's going to happen. So I hope that gives you some idea of what's going on in your body as far as dealing with this chemistry. You have to keep everything's got to be protected from being invaded. Basically, that's it. Okay, I showed you, I'm sure, the things in the medical book. And it was the endocrine glands and some other things I showed you. And they talk about hormones. Well, hormones basically are nothing more than the enzymes. Now, it says some glands also have non-endocrine regions that have functions other than hormone secretion. For example, the pancreas has a major endocrine portion that secretes digestive enzymes. So I showed you the pancreas. That's the big boy. That does a ton. And an endocrine portion that secretes hormones. So it does both. Islets of Langerhans, and then there's something else, I forget what it's called. But those were those little things that I showed you. As a matter of fact, here they are right here. Hold on. Look at that. Look at how complicated the body is. These are the things on the islets of Langerhans, I think. And you see, there's a border over here. They're only in a certain area. They're not everywhere. These aren't like clamshells or anything. I believe that's what this is. One of that, I believe it's the pancreas. Maybe. I can't be positive of that. But anyway, there's body parts from every part of the creatures everywhere, so you have to just be able to identify them anatomically, and then I'm sure you could do something with the chemistry. But anyway, there's 8 major endocrine glands, and they're all over, and the hormone is basically the enzyme. All right, an enzyme is not a catalyst. That I agree with, but you can't have one without the other. So it says one of the major differences between enzymes and hormones is that enzymes act as a catalyst. Okay, so they do the chemistry. Bzz, they break the molecules. All right, hormones act as messengers. Well, the enzymes just don't happen all by themselves, so you have to have somebody say, we need a problem, we got a problem over here. Remember Gokul said there's sniffers and then there's destroyers? Well, that's it right there. Right? One of them is a messenger, and the other one is the catalyst that does the reaction. So, situation solved. All right, see up here, this is the lymphatic network, and that means your lymph nodes and your garbage dump. Literally, it's the garbage dump. Now, what are we looking at here? This is main lymph nodes of the deep lymphatic pathways of the neck and the thorax. So this is deep inside. Every one of these is a lymph node. And you see they're all hanging around the blood vessels and so forth. Look at them over here. Now these are the ones that are superficial. Can you see that? Yes. This is the superficial, means that close to the surface. And they're the same thing. They're all over the place. In your armpits and all that. Now, then you get down into your groin area. Look at them down here. They're clustered around blood. They want to take this stuff out of the blood. They want to subtract all the nasty stuff. So those are the type of things that are doing the job of cleaning yourself out. And then they dump their contents through the lymphatic vessels, I think I showed you, into feces, or I don't know, really at that point they somehow get out of your body. All right, from all I can understand from what it talks about here, all it says is it drains the lymphatic glands into the lymphatic ducts, at that point they're just drained into the vein system, it looks like to me, which is the blood that goes to get cleaned by the liver and all that stuff. So once it's turned into lymph, it's malleable at that point and can wash out of your system. But these things have to break up the really bad, nasty stuff. It looks to me, that's what I'm taking out of that. Okay, my friends, I hope that made a little sense to you. And I threw a couple of different curveballs at you there. It went a little longer than I expected, but hopefully it's good information. And these long-suffering patients of COVID, and virtually every disease that is a chronic illness, means, I believe, that you are short of some type of bacteria that creates some type of enzyme, that creates some kind of chemical that goes out and does some kind of job to protect you. And normally they go flying up and down through that fluid-filled highway with a bacteria that has a propeller on it that turns 100,000 revolutions a second or a minute. And it's a fluid-filled highway. That's exactly what they call it now. All right, so I hope this made sense, and who knows, it may help somebody at some point. I love you all.